I'll show you straight line graphs. Equation of a straight line are represented in the form y equals mx plus c. Now what is that? Well, the m stands for the gradient. The number that will be in front of the x will be the gradient. What is the gradient? How steep something is. So that's flat, and then if I do that, it gets steeper and steeper. Right. So that's a positive steepness going uphill. That way, that's a negative steepness going downhill. So there'll be a number in front of the x that represents the steepness. That's called the gradient. And that value there represents where the straight line graph crosses the y-axis. Where it crosses, it could cross anywhere along the y-axis. Now look at all these. All of these are in the form y equals mx plus c. Y equals mx plus c. They've all got something in common. And they've got a number in front of the x. Even a fraction, decimal, negative numbers. It could be a plus and minus, and then a number and just a number. Could be decimals as well, like so, or even fractions. So all of these are in the form y equals mx plus c. These are straight line graphs. So if you come across anything like this, they are straight line graphs. Whereas if you come across something that's got an x squared in it or an x cubed, those are not going to be straight lines. But we'll look at another video in the future on how to do graphs of these. Right, I've already drawn a graph of, here, look at this one here, y equals 1x plus 3. This one, y equals 2x plus 3. And it gets steeper. Y equals 3x plus 3. So 1x plus 3, 2x plus 3, 3x plus 3. Oh, I've got one here. Y equals half x, only a half x plus 3. So these equations are in the form of the form y equals mx plus c. Remember, the first number in front of the x represents how steep the graph is. So this one's only 1x. You don't have to put a 1x. You can just say y equals x plus 3. You don't have to put the 1 in front. So that's a 1. It's not that steep, is it? And then it becomes a 2, a little bit steeper. 3, a lot steeper. This one's only a half, not very steep. You could have negative gradients. So for example, yes, before I do that, I need to explain. You're probably thinking, well, why are these numbers all the same? Plus 3, plus 3, plus 3. That's clearly because all of these graphs are going through the point 3, 0, 3. 3 on the y-axis. So remember, I said to you earlier on, that number there represents where it crosses the y-axis. All of these graphs cross here, 3 up the stairs, so that's why they're all 3s. I could have had something like this, for example. Let's say that one, I'll call it 0 along the corridor, minus 5. So if I was to draw a graph of that one, so the equation of that one would be what? Well, let's say y is equal to that one there. See that there? It's got the same steepness as this one. You've got this one over here. They're parallel. These are running parallel, so it's going to have the same gradient. Let's call it 1x. But because this line is going through minus 5 on the y-axis, I'm going to put minus 5 there. You could have negative gradients. So for example, choose a different color so it stands out. Let's suppose I'm gonna go through that 3 again. So let's say I got something like this now. That's going to be, I'm going to call it y equals to minus 1 x. Well, why is it a negative? Well, it's because it's going downhill. I put a 1 there. I know it's not accurate. I haven't got a square grid here, so just assume it's 1 minus 1x. But because it's going through 3, positive 3 on the y-axis, I'll put positive 3. If it was a little bit steeper, I could call that y is equal to minus 2x. 2 because it's slightly steeper, it's a negative because it's still going downhill. And what will the y-intercept be? It's going through 3. It's still going through 3, so it'll be positive 3. Right, this diagram's looking a bit complicated. Let's see if I can find a different colour. Yeah, this is going to stand out really well, isn't it? Right. I'll do just one more. It's going to go through that one then. And I will make it parallel to this one over here because I feel like it. Right, so here we go. Whoop. Right then, so what shall I call this one? Y is equal to, since this one, the black one, is parallel to this one, the gradient of this one here is already minus 2, negative 2. So it'll be negative 2x, but because it's going through minus 5 on the y-axis, negative 5. So that's it. If you unwind the video, it will look less complicated.